Alright, so this is question 2.5 and it's called sum list. So we're given two numbers that are represented by a linked list, and each node contains one digit of that number, and then these digits are actually stored in reversed order. So if you had the number 617, it would be stored in this linked list where the first node is 7 and then points to 1 and then 6. So you can see how that's the reverse of 617. And then we want to add 1295, which is represented by this linked list, 5 pointing to 9, to 2, then to 1. And that's the reverse of 1295. And what we want to do is we want to write a function that will add these two numbers, which are stored in reversed order, and then return the sum as its own linked list. So we're going to return 1912, represented by a linked list that's stored in reversed order. So it's 2 pointing to 1, to 9, then back to 1. So I just created a driver program that kind of creates these two linked lists. So we have that 716 here, and I just create the linkage between these two nodes. And then we have the second list, 5921, created here. And then I'm just using the node class where we just pass the value stored in the node, and then we have a pointer called next pointing to the next node in the list. So we then call our sumList function, and we're passing the first node in the first list, which would be the 7-digit, so kind of like the first digit in the number. And we pass the first node in the second list as a second parameter, and that would be the number 5 here, right? And so let's go to our function. Now, one important step that we're going to need is we really need to obviously calculate the result. And we're going to set this initially to 0, but we're also going to need the carry bit from each iteration. So we're going to be going through these numbers one by one. So we're going to look at 5 and 7, then we're going to calculate 9 and 1, then we're going to calculate 2 and 6, and then we're going to calculate 1 and, well, nothing. But each iteration, we're going to want to bring the carry bit that was calculated from the last. And so in the first case, we're going to do 5 plus 7, right? And so 5 plus 7 is then equal to 12. And so we have a carry bit here of 1, right? So then when we're doing the 90 plus 10, we're going to have this extra carry bit to bring over to use for that next calculation. So I'm just going to show you the code here, and that might make a little sense. We're kind of doing this one addition for each digit at a time. Then we move on to the next digit in the list. So we're going to have a while loop, and we're going to need at least one value to calculate our result on. So while list1 does not equal null, or list2 does not equal null, or the carry bit does not equal 0, right? Because we need at least one value to deem it worthy to be calculating another result for. And so if list1 node does not equal null, then we can add that to our current result. So we're going to do list1.data. And then we just kind of point to the next node in our list1 linked list. dot next. And so in this case, our first node on our list1 is 7, right? So that's kind of adding 7 to our current result. And then we will then point to the next value in our list1, which is 1, right? So it adds 7, and then we'll be pointing to 1 here. And so we're going to kind of do the exact same thing for our list2. So if list2 doesn't equal null, we want to add the value stored in that node. Then we want to move on to the next node in list2. And then finally, we're just going to want to add the carry bit performed in the last iteration. And so now, because we're actually going to want to produce a new linked list as our return here, we're going to create a node called output head, because we're going to want to maintain what is the head of this new list we're creating. That's going to initially be null. And then we're going to need a pointer for as we're kind of adding new nodes to our list. So this will be like output pointer equals null as well. And then finally, we are going to want to return our head to this new list. So I'm just going to add it there so I don't forget. And that's because that we're returning this new list as a result, and we're going to want to return the head so that this is kind of our print statement here, which we're going to want to print through at the end just to make sure we got the right result. So now we're going to create a new node. We'll just call this new node. Honestly, that's good. And this will be set to the mod of the result, and we're modding by 10 here, because if we calculated 7 plus 5, that's equal to 12, and so mod of 10 here is going to equal to 2. So we're just going to want to make a node for 2, and then that 1 here will be used as the carry bit. So mod of 10 will be the new node, and then our carry is going to equal the result divided by 10. And because it's integer division, that's going to take the 4. So when we do 12 divided by 10, that's going to equal 1.2, which an integer takes the 4, so that's going to return 1 in our carry bit. And so what we're going to do is, if our output head is null, then this is the first node in our list. And so we're going to want to set our output head just to this new node, because we need, our first node. And then because our pointer is pointing to nothing, let's just point it to our new head of this new list that we just made. Otherwise, we already have nodes in this list that we're returning, and so we're just going to set the output pointer equal to this new node. No, that's wrong. Our current node that we're pointing to, which is like the previous value that we just calculated, we want its next node to be equal to this new node that we just calculated, and then we set our output pointer to it. Right, and that makes it fully attached linked list. So we're just appending these new values. And then finally, we just need to set our result equal to 0. And that way, so that after we performed all these calculations, the result isn't being carried over to the next calculation. We just want to bring this carry bit over. Great, so I think that's it. I'm going to try running this. And that's 2191. Let's see if it's right. Great, and that's right. So it's 2191 as we expected, which in reality is equal to 1912. So the time complexity of this algorithm is O of n, where n is the length of the longest list. And then our space complexity, maybe you would call it O of n. I'm not quite sure, honestly. Maybe you could tell me in the comment section, but I would say it's O1, because the only additional list we're using is what we need for our output. It didn't really specify that you want to use this in place where you return one of your input parameters, so I'll call the space complexity O of 1. So great, I hope that helped, and I wish you good luck with the rest of your algorithm. So have a great day.